Hello everyone. We will be starting from the numerical integration. The first is trapezoidal. By the end of this session, you will be understand the trapezoidal rule and you will be able to approximate the integral using the trapezoidal rule. But before going to that, let me just tell why numerical integration? Why? Why not analytical integration? Why numerical integration? The reason is first, why to go for numerical integration is first is no analytic solution exists, and the second is if we are forced to calculate the integration by other means or methods. For example, if we'll consider this example, integration e to the power minus x, sorry, e to the power x square dx, integration from 0 to 2, and if we'll try to find out the analytical solution. What do you mean by analytical solution? Means if I wanted to find out the integration by our usual method, will not be able to find out. And therefore, in this, but still, we are interested in the in the integration of this kind of function. At that time, we will be going for numerical integration. Now we have a various methods for this numerical integration. Let us go and see the one method, that is a trapezoidal rule or trapezoidal integration in detail. Now, trapezoidal integration, the name itself will tell you that this is nothing but related to the trapezoid, right? Now, let us consider a curve. This is what is the curve. This is the curve. This curve is placed in the point. Points are from x0 to x6, right? Let us hide for this. Okay, fine. So it's this curve lies between these 2 points, x0 and x6. Fine. Now, what is my first thing is, if I am dividing this curve, at particular points. Now, if you'll observe this per points here, these are the points which I'm dividing this curve, or I'm noting down the points, chalking down the points on the curve. Now, but this one thing you can observe, this distance between these 2 points, they are equidistant. So my first is, this is what the integration I wanted to find out. That means I wanted to find out integration of f of x from the point A to B. That means the limits have been defined. That means we are doing here definite integral. Similarly, this is what the points, if you observe this points are equidistant. Now let us consider, for just for an understanding purpose, I have divided this curve into n equals to 6. That means I have divided this entire curve into 6 parts, 1, 2, 3, 4, 5, and 6 parts, right? Now what is this? This is what we have broke down this entire thing into 6 equal parts. But how we have done that? We have done it equally. How can we do that? We can find out like this x6 minus x0 divided by n equals to 6 here. So I could able to find out this distance, the distance between x0 to x1, the distance between x1 and x2, and so on. So this is what is the formula by which we can find out the points or the intervals. So in this case, either I have to understand how many number of intervals I need to divide. That means how many number of intervals I need to divide my integral, this function, and the end points of this integral. Now, this, if you'll observe this integral, the end points also we have got included into it, right? So placed at extreme endpoints and distributed evenly. But what exactly we are doing it here? Trapezoidal rule. So it's nothing but area under the integral. Now, if you'll observe here, whenever we are doing the area under the integral, we have formed here, we have joined this line, this 2 points, 2 consecutive points, just by a single line, or line passing through the origin. If you'll observe here, these are nothing but the trapezoid got formed here. Now let us understand what exactly it is. If I wanted to find out, suppose for example, I wanted to find out, consider this trapezoid here. Okay, for just for a understanding purpose, let us consider this trapezoid, so that is its a slope is little steep here, so that I can make you understand what is it. So suppose for example, take this one trapezoid here, which is from the x3 to x4 on x-axis. Now, if corresponding to this x3, and if I wanted to consider this point, what this point is? This point is f x3, right? This point is f of x3. and this point, corresponding point, is f of x4, f of x4, right? Now, if I wanted to find out the area of this trapezoid, that means what? I have to find out the area of this about triangle here, about triangle here. But what is this triangle? You know the triangle, this, the area of the triangle is half times the width and the breadth over here, height, the width and the height over here. So if you'll observe, suppose I wanted to find out the area, or suppose take it this as A1. What this A1 will give me? This A1 will give me half, right? Half. This is the length, which is, what is that? X4 minus X3. This is X4 minus X3, right? Into what? Into this height. What this height is? What this height is? This is f of X4 minus f of X3. So it is f of X4 minus f of X3 along y-axis, right? So this is what is the area of this above triangle. And if I wanted to consider the area of this rectangle here, the area, you know that how this area will, this is nothing but this length into this height. So this area A2 will give me here, A2 will give me here is equals to x4 minus x3 into, what is this height? This height is giving me f of x3, f of x3, right? And if I'll add these two and do some algebra here, I'm going to get the area of this trapezoid, right? The area of this trapezoid. Let us go and see what, how will it be. The next slide. So this is again, just for a reference sake, I have kept the same thing again here. Now, if you'll observe, this area of the trapezoid will give me delta x by 2 into f of xi minus 1 plus f of xi. So it's a general form of this, trapezoid. Now I have one trapezoid here. I'm going to get the area of this. You know, I have got the next, I've got the next, I have got the next, I have got the next. In this way, if I'm dividing this entire into n sub intervals, I'm going to get this area, something like this here. So integration a to b f of x dx is equals to delta x by 2 f of x0 plus f of x1 plus delta x by 2 f of x1 plus f of x2 delta and so on. If I have got n points, n different subintervals here, I'm going to get this. Now if you'll observe, there are few points are clubbing together. They will club together. So what are they? If you'll observe, this delta x by 2 into f of x1, delta x by 2 into this. So what will happen? This f of x1, this will come out and you will be getting the formula of the general trapezoidal rule as this, where my endpoints will have the coefficients as 1 over here. Okay, now from where this half has come? This half has come from the triangle part and this combination, or you can say the algebra. Because of this algebra, this is the half point have come here. And these are my extreme points, f of x0 and f of xn. So f of x0 and f of xn has come only once. That means the last point have come only once. Whereas in between points, if I'll observe, I've told you here that we'll be getting 2 times. So this half, so this is what I'm going to get it, f of x1, f of x2, f of x3. So in between points, extreme, except of extreme points, every function will get multiplied by 2. Every function will get multiplied by 2 over here. So this is what is the general trapezoidal rule I'm going to derive from the given curve. Let us go for first example, which we'll be going for in detail. Now, for this particular example, I have kept my calculator mode is in radian. Calculator mode is in radian, and this is 0 to pi sine square x dx. Why radian? Because I'm dealing here with the trigonometric function, and this limit is there. Okay. Now f of x. What is my first thing is n equals to 6. Now just let us see what all things we have been given here. F of x is sine square x, my function. My endpoint. What will happen with the delta x? Delta x is b minus a by n, that is pi by 6. So I'm going to get all my points like this. So it will be, I will move move from 1 to, actually it's from 0, because my lower point is 0. It will move from 0 to 6. And first point, so my f of x0, that is f of 0, that is sine square 0, is equals to 0. So this is what is my function, and I'm trying to find out the value of that function at each and every point. And each and every point. So what will be my next point? It's my next point is I equals to 1, that is pi by 6. So pi by 6 will give me the value f of pi by 6 sine square pi by 6, which is equals to 1 by 2 the square, which is 1 by 4. Similarly, it's 2 pi by 6. So if you'll observe, it's pi by 6. So we have started with 0, then to pi by 6, then 2 pi by 6, then it's 3 pi by 6. You can easily find out these values using the calculator, keeping the mode as a radian. Otherwise, it's a sine function. You can easily find out that sine 3 pi by 6. So what exactly we are doing? We are trying to find out the value of this function between the standard functions here, standard intervals. That is, you can say a principal interval, 0 to pi. So it's okay, always minus pi to pi. So 3 pi by 6 sine square pi by 2 and so on. So I'm going to get this as, so I'm going to get this. So here this way I'm going to get all those values starting from this 0 to this, and this 4 pi by 6, 5 pi by 6 here, and then here 6 pi by 6 is nothing but a pi, and I'm going to get the value. So if you observe here, the value of extreme points is 0 and 0. In between points I have got these values. So how my trapezoidal rule will move? My trapezoidal rule will move. The extreme sides I'll be getting only once, whereas this 1 by 4, this 3 by 4, this 2, sorry 1, this 3 by 4, and this 1 by 4 is getting added, but it will be getting added 2 times. Or you can say the add all of them and multiply with 2. So you're going to get the answer as, I'm just repeating the things, nothing else I'm doing it here. So this is what I'm going to get is 0 to pi this t6 because I'm dividing this entire thing in 6. It's been given to us. So delta x by 2 f of x0, as I've told you, the extreme points only once, and in between points we're taking 2 times. So I'm going to get my final answer as pi by 2. So this is known as numerical integration. Now, what exactly the exact value of this integral? That means by the analytic method is this. What we are doing it as a usual method, that sine square x is equals to that is 1 minus cos of 2x, and then 1 minus cos of 2x is getting integrated with respect to x, and I'm going to get, after putting the upper and the lower limit of this integral, we're going to get as pi by 2. So trapezoidal, in this particular case, in this particular example, trapezoidal, the approximation and the exact value approximation, they are going to coincide here, because the answer from both the methods we're going to get the same as pi by 2. Let us go for one more example. So it's n equals to 6 again, and this 1 to 7 here. 1 to 7 is the upper limit here. This is the function, and this is a approximate curve of this function here. Just for a safer side, or just for the sake of understanding, I have drawn the curve here. So it's 1 to 7, and the intervals have been given to us as 6. So what will be my, this 1 to 7 I need to divide into 6 intervals. How? That is, upper limit of this integral 7 minus 1, which is a lower, divided by 6, which is equals to 1 here. And therefore, this is nothing but the integral, and therefore this integral 1 to 7, 1 upon x cube plus 1 dx is equals to. Now, what exactly we have been doing it here? This f of 1 and f of 7 has come only once, whereas in between f of 2, f of 3, f of 4, 5 and 6. So if you'll observe, this delta x is equals to 1. That means this 1 to 7 interval we have divided into 6 equal intervals. 1 here, 2, 3, 4, 5, and this is 6. Now, while doing it, we have found out the value of those at the point, at the intervals, the point on the intervals. So we have found out the value of f of 1. That means we have kept it 1 upon the value of x, we have replaced here as 1. So we have got the value. Then we have got the value as f of 2 means 1 upon 2 cube plus 1. Then f of 3 is nothing but 1 upon 3 cube plus 1. F of 4 is 1 upon 4 cube plus 1, and so on. And we have got the answer as this. You can easily check the answer. Just understand the method thoroughly here. So whenever we are doing a trapezoidal, first of all, we are concentrating on how many numbers of the intervals have been given to us, and then the upper and the lower limit will find out this intervals, how many intervals, and what are the points on the intervals we have to find out, and then we will be doing it. We'll be finding out the value of that particular function at those particular points, and after that just for extreme points as once and the in between points as two times, and we're going to get the answer as approximation. Okay, now similarly, let us go for one more example. Again, I have kept the calculator mode as a radian here. But here, what is the change? Changes is n equals to 8. N equals to 8. So most of the time, they'll ask us to find out the interval. And otherwise, if it's not given, you can just go ahead with n equals to 6 is a standard, so that we will be getting the answers more accurate and more faster, and our calculations won't be so long here. That is otherwise more number of, see, if we'll take in under this curve more number of a smaller this intervals, you'll be getting the more accurate answer. You'll be getting the more. So however you are dividing this intervals, there's many, how many intervals here, how many trapezoids, you'll get the more closer the answer. So that means the error will be less here. So this is what is the curve, and we are dividing into 8 parts. That means the 0 to 4 into 8 means 4 minus 0 by 8, which is equals to half. And therefore, if you'll observe here, this points, this is my extreme point 0 to 4 here, and this in between points have been get aparted by just a distance of half unit here. So these are the 8 different intervals. We have formed it here, and these are the points 1 by 2, 1 by 1, 3 by 2, 2, 3, 5 by 2, and so on. And we are going to get, so this is just for a reference or the formula. Every time you need to put the formula so that you will understand it and there will not be any chance of making a mistake. So 0 to 4, cos of square root of the cos of 1 plus square root of x dx, which is getting approximated to this 1 by 2, because here if you observe my delta x by 2, so delta x in this case is 1 by 2 and divided by 2, and therefore it is nothing but extreme values as this, and in between points are getting multiplied by 2. Now what is this f of half? How can you calculate that? It's nothing but cos of 1 plus square root of 1 by 2, and the calculator value will give you this, and at the end you will get the answer here. My purpose is just to make you understand the formula. You can easily use the calculator and find out the values. Here the intention of this video is to make you understand the trapezoidal rule, how it has been derived, why numerical method, why not we can stick to some functions, some integrals we cannot able to find out using the analytic method, and we cannot able to reduce it to a one function, and that's why we are required here to go for numerical methods. Today's session we have discussed about the trapezoidal rule. In continuation with this lecture, we'll be dealing with the Simpson's rule or Simpson's integration in the next session. Happy learning!